Hello good people, I'm going to talk about scaling of fractions. In order to illustrate, I'm going to bring in 3 innocent lines of white powder. What is the nature of the powder? Well, it depends on your imagination and the types of parties you attend. The first line will be divided into 12 equal parts. Each section represents a 12th. The second line will be divided into 6 equal parts. Correspondingly, each section represents a 6th, and the third line will be divided into 3 equal parts. Each section represents a 3rd. On the first line, I'm going to color in a section that represents 4 12ths. On the second line, I'm going to color in a section that represents 2 6ths. And on the third line, I'm going to color in a section that represents 1/3. By inspection alone, we can see that these 3 colored-in sections represent the same length. And so I could say that 4 12ths, 2 6ths, and 1/3 are equivalent fractions. What if I want to express this 1/3 in terms of 12ths? Already we can see that 1/3 is the same as 4 12ths. But how do I show this conversion in a mathematical fashion? In order to answer that, I need to ask myself, by what number do I need to multiply 3 to get to 12? Because I want to convert a third into 12ths. Well, the answer is 4. However, in order to preserve the size of the fraction, I need to multiply both the numerator and the denominator by the same number. So in this case, it would look something like this. I would take the third and I would multiply it by another fraction. That fraction would be 4/4. 1 multiplied by 4 is 4. 3 multiplied by 4 is 12. But because we are dealing with fractions, I need to write in the division line as well. A couple of things to note here. I have not changed the size of the fraction. I have simply changed the way I express it. 1/3 is the same as 4 12ths. The second thing to note is that we have increased the number of the numerator and the denominator. So this is known as scaling up a fraction. Let me do the same thing for 2 6ths. I want to express the 2 6ths in terms of 12ths. Again, I know that they are equivalent fractions. I need to ask myself, what do I need to multiply 6 by in order to get to 12? The answer is 2. But once again, whatever I multiply the denominator by, I also need to multiply the numerator. And so 2 6ths will be multiplied by 2/2. And that will get me 4 12ths. I could say that 2 6ths has been scaled up to 4 12ths. If I absolutely insisted, I could take these 4 12ths and scale them up as well. As long as I multiply both the numerator and the denominator by the same number, everything will be fine. So, for example, I could take the 4 12ths and multiply them by 5/5. And that will give me 20 60ths. The size of the fraction has not changed. I have changed the way I am expressing that fraction. That was scaling up. But we can also scale down. When scaling down a fraction, we are looking for a common factor of both the numerator and denominator. In this case, we are looking for a number that both 4 and 12 are divisible by. Seeing how both 4 and 12 are even numbers, they are both definitely divisible by 2. 4 divided by 2 will give me 2, and 12 divided by 2 will give me 6. And so 4 12ths is the same as 2 6ths. I could take this further. 2 and 6 are also both even numbers, therefore they are also both divisible by 2. 2 divided by 2 is 1, 6 divided by 2 is 3, and so 2 6ths can be scaled down to 1/3. I did not have to do it in this stepwise fashion. Depending on my knowledge of the multiplication table, I could have said, well, both 4 and 12 are divisible by 4. 4 divided by 4 will give me 1, 12 divided by 4 will give me 3. At the risk of repeating myself, the size of the fraction has not changed. When we scale up or scale down, we are changing the way we express the fraction. That is all for now, and I will see you on the flip side.